Hi, welcome once again to our YouTube channel. Thanks for subscribing to our channel. Quickly, we want to look at the qualitative analysis or SWOT analysis for this Waec 2025 chemistry practical. We want to look at the SWOT analysis. That is what we want to look at. So we'll be just talking about some of the observations that were experienced or that were observed during the practical while we carried it out in the laboratory. So I'll just give us a rundown of what we are talking about. Firstly, here, when specimen C, which is in solid form, when it was diluted, when we added 5 centimeter cube of distilled water to it, of distilled H2O, we observed that it dissolves to give a pale blue solution. It dissolves to give a pale blue solution. And since it gave that color, first and foremost, it was totally dissolved. So we say that it is a solution that C is a mixture of soluble substances. A solution of soluble substances. That is what we have our A to be. Now, when we added this to litmus paper, when we tested litmus paper on this salt, we discovered that it turns blue litmus paper to red. It turns blue litmus to red. That tells us that C is acidic. C is acidic. Also, when we decided to fill the substance, we just decided to touch the substance to have a feel of how the temperature is. We discovered that the test tube felt hot. Test tube feels warm. That is as a result of the fact that the solution is exothermic. The solution is exothermic. Those are the things that we observed when we added distilled water and all of those things to this particular substance. Now, we went further to test this particular substance, and we discovered that when we added our C, when we added sodium hydroxide, dilute sodium hydroxide to our C, a portion of C plus dilute sodium hydroxide in drops. What we discovered is that we found a pale blue gelatinous precipitate. Formation of pale blue gelatinous precipitates was observed. Yes, that was what we observed from that. So inferring from this now, we decided that it seems that there is the presence of copper 2 plus. So copper 2 plus is present in that. And then this substance, sodium hydroxide plus dilute sodium hydroxide in excess now. Plus dilute sodium hydroxide in excess, we discover that precipitate remains insoluble. The precipitate that was formed earlier remains insoluble, and this told us or confirmed to us that there is what presence of copper 2 plus. Also, when we left this particular thing for some minutes, when we left it for 5 minutes, the precipitate turns, we discovered that the precipitate turned turned red. Precipitate turns brown red. This tells us that there is reducing sugar present. It tells us that there is reducing sugar that is present in that substance. Also, if after leaving, let's assume that, because another test, we reacted our sodium hydroxide with heat. That is after adding sodium hydroxide to our C, then we expose this to heat. Let me do it this way so we don't get confused. Plus heat. What we discovered there was that the precipitate turned brick red. Precipitate turns brick red. So it confirms the presence of reducing sugar. Reducing sugar present. That was another test that we observed, another thing that we observed while we carried out that particular test. Let's go for that. We also tested our substances, the C, our C, portion of C, which is already in aqueous form, plus dilute aqueous ammonia in drops. In drops of aqueous ammonia, we discovered that a pale blue gelatinous precipitate was also formed. Formation of pale blue gelatinous precipitates. Pale blue gelatinous precipitate. It was also found in that particular substance. So that also tells us that there is copper 2 plus. Copper 2 plus is present. Yes, that also tells us that copper 2 plus is present. And then in excess, aqueous ammonia, we discovered that the precipitate dissolves to give a deep blue solution. The precipitate then dissolves to give deep blue solution. This confirms the presence of copper 2 plus. So this was a test that we carried out using aqueous ammonia. Portion of C plus barium chloride. White precipitate formed. White precipitate was formed, and that tells us that we could be having SO4 minus. That's a confirmatory test. That's a test for SO4 ion. It could also be SO3 2 minus. We could also be having transcarbonate there, CO2 minus ions. All of these ions could be present as a result of that observation that was seen. And then when we reacted this with dilute HCl, which dilutes HCl, we discovered that the precipitate became insoluble or was insoluble. Precipitate is insoluble, and from this now we can deduce that there is the presence of SO4 ion. SO4 2 minus ion is present. We can deduce that from that particular experiment. Okay, let's see where we added our hydrogen first, our hydrochloric acid first. In a scenario where we add our hydrochloric acid first, when we add our hydrochloric acid first, what we observed was that there was no visible reaction. No visible reaction was observed. But when we now add barium chloride to the substance, we discovered that there was a formation of white precipitates. Formation of white precipitates. And this tells us that we have SO4 2 minus ion present. And then the next one there, the next test we did was on we made use of Fehling's test. We carried out Fehling's test. So portion of C plus Fehling's solution Fehling solution A and B. What we observed from that was that we had light blue gelatinous precipitate formed. Formation of light blue gelatinous precipitates. Gelatinous precipitate, and that tells us that we could be having copper 2 plus ion present. Yes, and then when we decided to apply heat to it, when we applied heat to it, precipitate turns brick red. The light blue precipitate that was formed earlier turns brick red. It turns brick red, or even we could call it yellow brown color. Yellow brown color. This confirms that there is presence of reducing sugar. Reducing sugar present. Next test we carried out was using sodium hydroxide and Fehling's solution. Portion of C plus sodium hydroxide first. Remember, we already did that. And then plus Fehling's solution. Fehling's solution A plus B. What we observed there was light blue precipitate. Formation of light blue precipitates. Precipitate that remained even when we added the Fehling's solution. And then it also confirms the presence of copper 2 ion. It confirms the presence of copper 2 ion. And then we decided to warm the mixture. So we warmed the mixture, and then precipitate turned brick red. Precipitate turns brick red. This tells us that there is presence of reducing sugar. Reducing sugar present. So these are the things that we discovered or encountered while we were doing the experiment. Starting from the first one here, we discovered that we have our test when we used our C plus distilled water, when we added 5 centimeters of distilled water to it, and then we tested with litmus paper. All of our sample C dissolved in the water, in the distilled water, to form a pale blue solution, telling us that our mixture is a soluble substance. And then the test of litmus, it turned only blue litmus paper to red, telling us that it is an acidic substance. And then when we felt the test tube, it felt warm. And then we went further to carry out all the other series of tests, testing with sodium hydroxide, which gave us pale blue gelatinous precipitate. And then that it was telling us that there was the presence of copper 2 plus. We also had that of sodium hydroxide in excess, and then the solution still had the precipitate in it. The precipitate did not dissolve, and then when we left for 5 minutes, we found out that on standing, the precipitate that was pale blue started to turn red, started to turn brown red, and when we applied it to it, it turned brick red. And then this source with ammonia solution, with aqueous ammonia, we found out a pale blue gelatinous precipitate was also formed, and in excess the precipitate dissolves and then turns the substance into deep blue solution. So that confirmed the presence of copper 2 plus. And then we went further to test for the anions. There we tested the salt which was given with barium chloride and dilute HCl. When we added barium chloride, we got white precipitate, and then that told us that we had all of these substances that we have here: SO4 2 minus, SO3 2 minus, and the rest of those. And so when we tested with dilute HCl, the precipitate was insoluble, confirming the presence of SO4 2 minus. And then we also went further to talk about the addition of dilute HCl directly to our C. So there was no visible reaction in that particular experiment. And then when we added barium chloride to it, formation of white precipitate was observed, and then that confirmed that there was presence of SO4 2 minus. We also went further to look at portion of the C with Fehling solutions. So when we added Fehling solutions A and B to that particular substance, there was formation of light blue gelatinous precipitate. That also confirmed copper 2 ion. And then when we applied heat to that substance, our portion C plus Fehling solution and then heat, precipitate that was light blue turned brick red or about yellow brown, and that told us that there was presence of reducing sugar in that substance. Also, we now confirmed testing with sodium hydroxide and Fehling solution, we found formation of light precipitate. Sorry, this is supposed to be light blue precipitate, and this told us that there was copper 2 ion in that substance. And then when we applied heat to it, the precipitate turned brick red.